Welcome back. In this lesson, we're going to be focusing on storage and we're going to be looking at primary and secondary storage. So far, we've just looked at input and output devices and we looked at the processor or the CPU. Memory is required because we want to store data for retrieval later on. Perhaps you want to save something and maybe access that a few days later, or even a few hours later, or even a few minutes later. Primary memory is the computer's main memory, and this is directly accessible by the CPU and often much faster than all other types of storage. Now, you'll probably hear me interchange the words primary memory, primary storage. They're more or less the same thing. Memory and storage are often interchangeable. However, to make the distinction between RAM and ROM a lot more easier, we call it memory because it's random access memory and read-only memory. And for all other devices like hard drives, SSDs, CDs, we call it secondary storage. Could you call it secondary memory? Of course you could. That's possible. However, we generally call it primary memory and secondary storage. Anyway, secondary storage is non-volatile, which means that it doesn't change. And this medium allows us to hold data until it's deleted or overwritten. Some types of primary memory can be volatile, for example, RAM. We'll look at all of that in a moment. However, secondary storage is always non-volatile. Secondary storage is where programs and data are kept on a long-term basis. So if you want to save something for weeks, months, years, that's where we'll go. There's another term called offline, which refers to non-volatile storage that can be easily removed from the computer. So if your secondary storage can be removed from the computer and plugged into or taken away and kept somewhere else for safekeeping, it's also called offline storage. Now, this is often used to transport data and keep backups for protection. And often offline storage and secondary storage are called secondary storage. So we group everything together. So the essence is that there's only two types of memory, primary memory and secondary memory, or primary storage and secondary storage. And primary memory is directly addressable by the CPU, contains RAM, ROM, and cache memory. Secondary storage is not directly addressable by the CPU. It needs to be loaded up into primary memory first. All secondary storage are non-volatile devices, so that means that we can save things for the long term, and they can be external or internal to the computer. And examples include hard disk drives, solid-state drives, DVDs, memory sticks, Blu-ray discs, and so on. So try to make sure you memorize what you see on this particular screen. So let's start by looking at the first type of primary memory, which is called random access memory. Now, RAM is directly accessible by the CPU and it's a lot faster than secondary storage like SSDs and hard disk drives. Any open programs or files on a computer that you are working with are temporarily stored in RAM whilst being in use. So the word temporarily is crucial because RAM is volatile. So that means that any data that's stored in RAM will be lost when the power is turned off. This makes RAM unsuitable for long-term permanent storage of data. Therefore, we need to copy this data onto a secondary storage device in order for it to be saved. And similarly, we'll need to load things from hard disk drives to get that into RAM so it can be used by the CPU. RAM can be therefore read from and written to, and data can be changed in RAM itself, and it can be used to store data, files, part of an application, or part of the operating system that's currently in use. So the term currently in use is very important. It normally gets you a mark. RAM is relatively expensive because it's super quick, and typical capacities of RAM are measured in gigabytes. 8 GB, 16 GB, 32 GB are common capacities these days. Computers operating with a capacity of RAM above the recommended minimum will benefit from better performance and multitasking. So if you stick to the basic minimum RAM, chances are your computer will struggle. So upgrading the RAM is a quick fire way of improving performance. Now, typical applications of RAM include the storage of applications and data that's currently in use. So you need to make sure that you relate this to any kind of scenario that's given to you in the exam. RAM comes in two different flavors. The first one is called dynamic RAM. Each DRAM chip consists of millions of transistors and capacitors. The capacitor holds the bits of information, for example, 0 or 1. The transistor acts like a switch. It allows the chip control circuitry to read the capacitor or change its value. So they both work together. Now, this type of RAM needs to be constantly refreshed. That is, the capacitor needs to be recharged every 15 microseconds or something like that. Otherwise, it will lose its value. You need access to current. If it wasn't refreshed, the capacitor's charge would leak away very quickly, and that means data is lost. Now, DRAMs have a number of advantages over the second type of RAM, which is called SRAMs, and we're going to be looking at that in a moment. So DRAM is much less expensive to manufacture than SRAM. It consumes less power than SRAM, and it has a higher memory capacity than SRAM. Its disadvantages include that data needs to be continually refreshed, otherwise it fades away, and this continually refreshing of data takes time and reduces performance speed. The second type of RAM is called static RAM or SRAM, and a major difference between SRAM and DRAM is that static RAM does not need to be constantly refreshed. SRAM makes use of flip-flops which hold each bit of memory. Now you'll study about flip-flops in a bit more detail at A level. However, as a result, SRAM is much faster than DRAM when it comes down to data access. Typically, access time for SRAM is 25 nanoseconds and for DRAM is 60 nanoseconds. SRAM is commonly used in cache memory. Memory cache is a high-speed area of memory which is super effective because most programs access the same data or instructions many times. By keeping as much of this information in SRAM, the CPU avoids having access to the slower DRAM. So what happens is, just like secondary storage is slow and it's loaded into RAM, RAM data is loaded into SRAM data or the memory cache. So you normally will have terabytes of storage on your SSD, but you might have gigabytes of storage on your RAM, and then you will probably have megabytes of cache. Now, the advantages compared to DRAM are that data on SRAM does not require refreshing, therefore it's much faster than DRAM and it consumes less power. However, it's very expensive. Therefore, you end up getting less memory on these type of chips as there is a lot of complicated circuitry involved. So do pause the video and have a look at the differences between DRAM and SRAM which are on screen. DRAM consists of a number of transistors and capacitors, whereas SRAM uses flip-flops to hold each bit of memory. DRAM needs to be constantly refreshed, whereas SRAM does not need to be constantly refreshed. DRAM is less expensive to manufacture, whereas SRAM has faster data access time than DRAM. DRAM has a higher memory capacity than SRAM, and generally RAM is constructed from DRAM rather than SRAM itself. SRAM is used to make memory cache. Now, in certain cases, DRAM can consume less power than SRAM because the cache will always contain some data, whereas RAM can stay empty, so you don't need to constantly refresh it. The second type of primary memory is ROM, which is read-only memory, and this is non-volatile. This means that the contents of ROM cannot be altered. ROM is often used to store the startup routines in a computer, example, the BIOS or the basic input-output system. This is the first bit of code that loads up, and then the operating system loads, which gets loaded into the RAM. The main features of ROM can be summarized as follows. ROM is non-volatile. The contents of the memory remain even when the power is turned off. Therefore, it's a type of permanent memory. ROM is often used to store the startup instructions, which is the basic input-output system, and this occurs when the computer is first switched on. The data or contents of the ROM chip can only be read, they cannot be changed. Now, there are some types of ROM chips which you learn at A level that can be reflashed, and they're called EEPROM or PROM, but you don't need to know that for IGCSE level. Now, the typical applications for ROM are to load up the basic input-output system or the startup instructions. So if you're thinking of a device, ROM chips will be used to store the startup instructions, and the RAM will be used to load any particular application that the user wants to use. So if you're given a scenario, you need to make sure that you use both of these and give a valid reason for use based on that scenario. Okay, so this is another important screen for you. Pause the video and make sure you know the differences between RAM and ROM. RAM is a temporary memory device, ROM is a permanent memory device. RAM has volatile memory, ROM is non-volatile memory. RAM can be written to and read from. ROM data once stored cannot be altered. RAM is used to store data, files, program, or part of the operating system which is currently in use. The word currently is very important here. ROM is always used to store the basic input-output system or the BIOS and other data that's required for startup. RAM can be increased in size to improve the operational speed of a computer. ROM can't. Once you fixed ROM on the motherboard, generally it stays the same. A moment ago, we were talking about how RAM and ROM are both required for the operation of a device. The application of primary memory is crucial, and generally you get an exam question that asks you about it. So on screen, you see an example. A remote control toy car has circuitry which contains both RAM and ROM chips. The remote control is a handheld device. Explain the function of RAM and ROM chip in this type of application. Now, in these type of questions, consider the function of each type of memory independently. For ROM, you will need to have the factory settings such as the remote control frequencies. You might need to store the startup routines when the toy car is first switched on. You might need to store the set routines, for example, how the buttons on the handheld device control turning left, acceleration, stopping, and so on. The RAM part will be used by the user who may wish to program their own routines in there. For example, there might be some sequence of instructions that they want to store in the RAM. The RAM chip will store the data or the instructions received from the remote control unit. For example, there might be a sequence of buttons the user presses, and that's stored in RAM. Okay, that's all for today. Hopefully, you should be able to answer the following questions. What are the differences between primary and secondary storage? What is meant by RAM and ROM? What are the differences between SRAM and DRAM? What are the differences between RAM and ROM themselves? And you should also be able to explain the use of RAM and ROM in devices such as smart TVs, games consoles, and so on. If you do have any questions, please do get back to me. Otherwise, I'll see you in the next one.